for instance, a gamma distribution. Do you know that from gamma we can derive beta distribution? In this class we've done gamma, right? We've also done beta, but we can derive beta distribution from gamma. Please, I need you to pay attention. Now, you know, when x follow gamma with parameter alpha beta, we have f of x equal this. Right? We have this. Now, what I want to do now, if beta equal to 1, okay, we're actually going to have right? This is also a gamma distribution, but a gamma distribution of one parameter. This is a gamma distribution of 2 parameters. Now, you know what I want to do now? If x1, okay, follows gamma with parameter alpha 1, and x2 follow gamma with parameter alpha 2, okay, where x1 and x2 are independent, where x1 and x2 are independent, okay, obtain the distribution of y1 equal x1 over x1 plus x2. Please, I need you to pay attention. Okay, you know what I want to derive? This is what we're going to do. We want to derive, this is derivation of beta distribution. You know, you saw that we were using beta distribution the other time. It was derived. How do we derive it? And I needed to pay attention. Okay, I told you, this is a 1 parameter gamma. Now, if x1 follow a 1 parameter gamma with parameter alpha 1, and s2 follow s2 is also a gamma variate with parameter alpha 2, and x1 and s2 are independent, okay, obtain the distribution of y1 equal to this. You know, at the end of the day, you know what we're going to get? If you obtain the distribution for y1 will be a beta distribution. Okay, why? This is looking like a probability, right? x1, s1 is also part of D. That's like a probability, right? Now, I need, you know what I need you now to do? I need you to focus on the board. If you don't understand, you ask question. Now, I want to start the proof. Okay, now, right now, you're given here y1 equal x1 over x1 plus x2. But we cannot go from 2 variables to 1 variable. Therefore, I need to introduce an artificial variable. So I'm going to say y2. Now, whenever you have a fraction like this, and you want to introduce an artificial variable, you use the denominator, okay, which is this. The denominator is the total. Now, you know what I've done? I've created an artificial variable that I'm going to integrate out later. Now, I need to find the inverses. Okay, find inverses. Okay, now if I want to find the inverses, I can start from here. Please look up x1. x1 equal y1. What is this? y2. Any question? I found the inverses for x1. Then I'm going to come here. What is my y2 equal? My y2, what is x1? y1, y2 plus, what is x2? Let me see. Oh, sorry. I'm finding x2, sorry. Now, I want to find this guy. x2 equal y2 minus, what is x1? y1 y2. Is there anyone who doesn't understand how I find my inverses? Okay, you solve for x1 and x2 in terms of the new variables you actually go into. Okay, now the moment you're done with that, the next thing you actually are going to do so the next thing you're going to do is, because we are told that x1 and x2 are independent, you get the joint for the old variable, of course, which is going to be this multiplied by that, because it's x1 and x2 are independent. Now, when x1 follow gamma, okay, now x1 follow gamma with parameter alpha 1, f of x1, of course, is going to be this guy. So x1 alpha 1 minus 1 exponential raised to power this gamma alpha 1. Then f of x2 is going to be this. You see that? Now I want to multiply them because they are independent. Okay, so f of x1, x2. So multiplying them, I'm going to have this. Any question on that? Multiplying them, I get a joint, right? Now, after getting this joint, you know what I'm looking for? I first want to get f of y1, y2, which is going to be the joint of the new variables I'm going into. And if I want to get that, I'll first need to do x1 in terms of y1, y2, x2 in terms of y1, y2, multiply by determinant of Jacobian. That's how I'm going to get that. Now, it's trying to say here, wherever I see x1, I should put this. Wherever I see x2, I should put this. I'm multiplying by the Jacobian matrix. Now, if I want to set up my Jacobian matrix, I'm actually going to come here, the x1, so it's going to be the x1, the y1, the x1, the y2, the x2, the y1, the s2, the y2. Now, right now, okay, what is the x1, the y1? The x1, the y1 is y2. Y2. What is the x1, the y2? Y1, right? The x2, the y1. The x2, the y1, that is negative y2. Negative y2. Then the x2, the y2. The x2, the y2, that will be 1 minus y1, right? 1 minus y1. Okay? Is there anyone who doesn't understand how I set up my Jacobian matrix? Is there anyone? I differentiated this guy here and this guy here. And that may look like a partial derivative. Yeah, go ahead.
So you differentiate with respect to x1, y1 both?
Yeah. Look at that. The x1, the y1. The x1, the y2. The x2, the y1. The x2, the y2. Each of these are different.
Okay.
But you have to maintain. If you want to do x1, x1. x2, x2. It has to be different thing. Does that make sense? And that's what we've done. So by the time you now multiply, you get the determinant of this. 2 by 2. Determinant of 2 by 2. So y2 into this minus, okay, another minus y1, y2. This is going to be y2 minus y2, y1 plus y2, y1. So this cancels that. Okay, the Jacobian is y2. Therefore, the determinant, the absolute value of that is y2. Now, I got that to be y2. All what I just need to do, I need to come here now. So I'm going to write f of y1, y2 equal, wherever I see x1, I'm putting y1, y2. Okay, y1, y2 raised to power alpha 1 minus 1. What about x2? okay, y2 minus y1, y2 raised to power alpha 2 minus 1, then exponential raised to power minus. What is x1 plus x2? Y2, okay? Y2, okay, divided by gamma alpha 1, gamma alpha 2, then multiplied by the absolute value of Jacobian, multiplied by Y2. Now, you know what happened here? I've completely eliminated X1 and X2. I got it joined right now. All I just need to do is to simplify that. I just need to simplify that. You can take a picture if you, but this is being recorded anyway. So now, f of y1, y2 equal, okay, y1 raised to power alpha 1 minus 1, y2 raised to power that, simplifying that guy, simplifying this guy. Now, do you know that here, if you factorize y2 into 1 minus y1, okay, each of them is going to be, this is going to be alpha 2 minus 1, alpha 2 minus 1, right? If you factorize that out, then exponential is power minus y2, okay, multiplied by y2, gamma alpha 1, gamma that. Now, we need algebra here, okay? If you want to do algebra right now, okay, let's bring y1 out. Y1 raised to power this, okay? Now, it's a function of y1. We're bringing it out. Can you see that? Okay, now what are we left with? Y2, y2, y2. Let's combine that. So if I write y2, okay, I think here is alpha 1. So alpha 1, okay, plus alpha 2 minus 1 plus 1. I'm going to have that. Okay, divided by, oh my God, this is looking like something. Now, this is f of y1, y2. Now, if this is